Microservices and Distributed Systems with Dennis van der Stelt.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company empowering .NET teams to be highly effective, able to deliver world-class results through its ClearMeasure way for effective software teams methodology. Quick announcement, my architect forums are going strong. They've been going all year. Signups for the next session are up. And if you lead a software team and are looking to collaborate with peer architect leaders, then just go ahead and sign up at the link in the show notes, and we'd love to have you in the conversation. And for those who are looking for the Programming with Palermo video podcast, just search in any of the directories and you'll be able to find it. So my guest today on the show is Dennis van der Stelt, and he's a software architect who loves building distributed systems and the challenges that they bring. And to be better than the day before, he continuously searches for better and new ways to improve his knowledge on architecture and software development. And what he learns, he tries to share through numerous articles and presentations and posts on his blog. And if you want to chat, you can ping him on Twitter. And his handle is at DVD Stelt, DVD STELT. Dennis, welcome to the show. How are you, sir?
Thank you very much. I'm really, really good. I'm honored to be here. Thank you very much.
Oh, my pleasure. My pleasure. And just recently, for those who may not have heard you speak before, you've done some conference speaking lately on distributed systems, haven't you?
Yeah, that's a topic that I find very interesting myself. And I can get very enthusiastic about all matter of topics related to distributed systems. And when I get enthusiastic, I have to share whatever I've learned or whatever. And that's why I do conferences like NDC, ORDEF, Build Stuff, some others, and recently Kansas City Developer Conference.
Yeah. Now, for those who haven't heard you speak anywhere, just for context, what are maybe some of the key points in your professional history that kind of steered you along this path and do a heavy focus on distributed systems on the Microsoft platform?
Well, when I just started, it was a very long time ago. I already was like for a hobby. Doing software development, and then I started doing it professionally. And at some point, I got in contact with web development, and I was like really pulled into that. And after quite a few years, I thought I've seen quite a bit of it, and I was more and more introduced into distributed systems where multiple components are pulled out of the monolith and they have to communicate with each other. And I got dragged into messaging, which solved a lot of problems I was having, or challenges rather. And it's not a solution to everything, but it's like an additional tool set that you get handed to solve all kinds of problems. And for some reason, it even sticks with me, and I find the challenges very interesting and entertaining to solve. So that's what I do most of my day.
That's an interesting word, entertaining to solve.
Yeah, it is. I mean, so currently I work for a particular software, and we make end service bus. And lots of our customers, they struggle with building distributed systems. So I try to help them out as much as possible. From, explaining to them that eventual consistency is possible, to setting up an entire proof of concept or helping them out with some architectural challenges. And I really, really enjoy doing that. And all the knowledge that I've gained over the, 20, 25 years or something, share that with lots of other people. So both customers at conferences, and hope I can get others as enthusiastic as I am.
Yeah. Well, we'll include a link in the show notes to Particular and In-Service Bus, because in the .NET world that I'm aware of, it's the most complete asynchronous distributed messaging framework out there on the commercial side. And I think I first used it somewhere in the 2000s, even before version 3, in the open source transition, somewhere back then. But I want to address just the concept of distributed systems, because I always recognize that the number of developers in our industry slinging code has doubled in the last 7 years. And so you have a lot of people that are early in their career, and it's easy to take for granted the things that I or we have learned in our past and think, oh, of course, everybody knows that. That's old. But I just want to ask you, just with fresh eyes, with all this context in the background, and with so many of the tutorials online being about process A and process B, and one uses a web service to call the other, and then boom, I'm distributed. Can you define the essence of distributed systems and how one should think the first time I realize, you know what? All this code shouldn't run in this one process. I now need a second process. How should I think about the two communicating?
Well, it's you can have different views. I mean, if you, for example, build a website and users make use of that website, there's part of it that's running in the browser, part of it is running on the web server, and oftentimes data is stored somewhere in a database. That means there are already multiple components, and especially if there's logic inside the web application that communicates with the backend, you already have those different processes. But yeah, I think in essence, it's those components that need to communicate, and each does their own part. So even if you just have a website with some logic in there and some backend processes, or just some, I don't know how we call that code behind, and just the ASP.NET or ASP.NET MVC or whatever language and framework and platform you're using. Those need to communicate with each other. And then there's, for example, remote procedure calls, which, for example, uses web services or HTTP requests, but it can be binary. It's basically when one process calls the other and basically expects a result. You can also throw something over the wall and say, hey, please do this. But the other side basically gives you a sign like, I'm ready. And it could be that then in the background, some stuff starts running. But there's also other mechanisms like messaging, where you literally fire off something to another component, and you don't really wait for an answer. You just assume that the other side will pick it up once it's ready. And there are multiple alternatives to that as well.
In the thinking in distributed systems, so much of the speaking that I've seen you do and others are about asynchronous messaging between components of a system. Is that, in your opinion, always central to distributed systems, or is it 80% of the time you need to go that way, or is it just maybe a few select times that you need to go that way? How do you generally think about that?
Well, that kind of depends. The way I've picked it up in the recent years is that I use it more and more. And then we might call it something like an event-driven architecture. But I wouldn't start with messaging. I would probably start with RPC, remote procedure calls. So in ASP.NET, that could be some web API project or whatever with controllers and everything. But at some point, you start sending data to the backend, and the backend services, or especially the database, isn't always available. And it's not so much because a database can go offline. It could also be because some data is locked inside the database and you have to wait for it, or you become the victim of a deadlock. Some exception is thrown, and then some code needs to be able to handle that. And with messaging, when I first got introduced to messaging, it was basically when there was a crucial part in our system, you could say like storing the order of a customer. And because various reasons, sometimes the order was lost. And we always logged some exception message. So we knew how often the exception occurred and how often our order was unable to submit to the database. But we didn't really store the data of the order itself. So the actual order was gone. When we started using messaging, it's basically you put the data inside a message, put it on a queue, and then it just sits there until some other process or some other component picks it up and starts processing it. So I still remember, for some reason, I was looking through some very, very old emails or conversation, and I noticed that the CEO of a company I used to work for, he was like panicking because he noticed that the database went down in the evening or in the night, and like, oh, how many orders did we lose? And I said, well, we didn't lose any order. They're still in the queue. So I'll just run them through the component again.
Yeah.
And everything is can be processed as if nothing happened. And I can still remember his replies. It was something like, we can do that? So coming back to your question, in that moment in time, I was probably, I don't know how many RPC calls there were to the backend and to the database, but there was literally one call that was done via asynchronous communication, via messaging. But since that moment, I started embracing it more and more, up until a point where way more was happening through asynchronous communication. So, for example, I started submitting the order to the backend via a queue. I picked up the order, processed part of it, and started publishing events. So a component publishing events, apologies, has no idea who's listening, but you could, after this component publishes an event, after half a year or whatever time frame, you can introduce another component that completely runs distributed on its own and says, I'm interested in those events as well. And from that moment, it starts listening to those events without changing the publisher. And at some point in time, you have 25 components listening to all those different events. And you start introducing more and more, embracing the concept more. And at some point in time, you can probably say that you're using or building an event-driven system. And then you have much more asynchronous messaging. But I doubt, I'd have to think really, really hard to come up with an actual number, but I doubt it's ever more than 50%. Like most calls are, you need something in the user interface or in some API or whatever.
Immediately.
And you need the data immediately. And I've seen people where I've told them how valuable messaging can be in your tool set.
Yep.
And they call it like the pendulum swings too far. So it swings from one end completely to the other end, and they start querying all data using messaging. That's not what you use messaging for. You need the data as fast as possible. And even though messaging is very fast, because previously I said like the message is in the queue until some component decides to pick it up. This could literally be milliseconds. But if you decide that the component should be taken down or upgraded or whatever, or it's really, really busy, then the component will take time before it picks up the message. So it could be milliseconds, but it could also be minutes, theoretically.
Yeah, that's a good point. I liked your point about starting with synchronous distribution and then moving to asynchronous when you find the benefit. I'm thinking all the tools out there that do performance profiling or debugging or logging, their primary use case is in a particular process. So if I have so many different processes and different threads that are going on, I have asynchronous boundaries in multiple places, becomes just harder for me to trace what is actually happening.
Correct, yes. And that's probably one of the downsides. But even if you're using RPC, or if you're using remote procedure calls, there's still this entire, the stack trace that we're used to, and it's now split up over multiple components, but they're still quite easy to track. And with messaging, that stack trace, even if it's not an actual stack trace, because it's hopping over multiple processes, you can get completely lost in what happens to your messages. So that's one of the downsides of using asynchronous communication, that you also can't debug it. It's not like you start 6 processes inside Visual Studio or JetBrains Rider or whatever, and then set breakpoints, because all those processes, they run somewhere else. They pick up a message whenever they feel like it. So it's much harder to trace and to debug, etc. And yes, it involves probably quite a bit of documentation, trying to figure out which message goes where.
Yeah.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
I like to ask the question, who decides what happens when things go wrong? And if an example is, if I have a button, if I'm bidding on an eBay auction or some item and I have a bid and I'm going to outbid somebody else and that somebody else needs to get a text message. If I click the button and somehow Twilio or my SMS provider, that system is down when I try to call over and say, hey, this text message needs to be sent. If the user should be the one who handles that bad thing happening, well, then, we can just take the error and go all the way back up and say, hey, something happened with sending a text message to the person that you just outbid. That's a bad example. So obviously you wouldn't do that. And so then we have to ask the question, okay, can we have some code logic handle the bad thing happening? Or does a system administrator need to have, because if the user can't handle it, then the synchronous nature breaks down. Whereas if we have a queue, just as simple as sending text messages, and it goes down, well, the user just goes along with their merry business, and then we can decide, do we replay those messages automatically when the provider comes back up, or in certain situations, messages that are minutes old, hours old, do they expire and are not useful anymore? But that gives us another boundary, because something bad is going to happen. And I've liked that question. Are there any other questions that you find yourself asking to kind of ferret out the decision of where some of those boundaries should be?
To get back to your question or example, it's like if a text message needs to be sent and some third-party text messaging provider doesn't work, I think it's the responsibility of the component that you build or that we build to send the message, right? It receives, and that sends the text message, it receives a message from the queue. So that component that needs to talk to the third-party provider, that's like a technical thing that needs to be solved. And that single component is responsible for it. So it needs to retry a couple of times and preferably not immediately move it aside into a dead letter queue and forget all about it. For example, and Service Bus has this thing of delayed retries where we say, okay, if we can't immediately retry it a couple of times, let's wait, 20 seconds, a minute. That's all configurable. And then retry again, because like this third-party provider could be offline for a little bit. Could be a network hiccup and come back fairly quickly. But then if it keeps failing, because maybe the way you communicate with third party isn't correct, then you need to put aside the message. Some developer comes in, fixes the problem. But there are also issues that, for example, you could talk to a third party provider to take some money from a credit card. But if the credit cards company says there's not enough money, right, then it's the responsibility of the system. So the component talking to the third party credit card company says, I fail in doing this, then it becomes not a technical issue, but more a business related issue. And we need to figure out what the processes are around those. So it could publish a message or send a message back saying like, I failed to succeed at the thing that you asked me to do. And then another component could say like, well, we need a process. And then you have to talk with the business, like if it fails, what would you like me to do? For example, one thing that Amazon does, which I think is a great example, is when you have something like the Oprah effect or, Winds of Winter of George R.R. Martin finally is released after 12, 13 or 14 years, and everyone wants to buy his latest book to figure out if he can hopefully write a better book than the writers of season 8 can. Everyone starts buying the book, and suddenly they have 1 million customers purchasing the book. They don't have 1 million books in store.
Yeah.
But because a message is put in the queue, they did sell it. So if they figure out we don't have enough books, there are processes in the background with Amazon, and sometimes they'll back order, they'll notify you, it takes a little bit longer, or they won't notify you at all. Sometimes they're unable to fulfill the order at all. And then they'll send you back a coupon code or whatever worth the money that you spent. And apparently, when you tell Amazon, you say, I don't want a coupon, I want my money back. That's also inside their business process to deal with those kinds of things. You immediately get your money back. But apparently, a very, very large percentage of people, they just accept the coupon.
Yeah.
And they start purchasing something else.
Right.
So those are all kinds of ways of when you say like, who's responsible for if something happens? It depends if it's a technical error or a business error or whatever. But your question was, are there other questions or other? I would like to mention something that I noticed. First of all, whenever I start talking to people about asynchronous communication and messaging, they say, well, what if this happens and then this happens? And it's like, this is so much more complex than when I just did the synchronous communication. And I say, well, if you think about it for a minute, you had the exact same problems when you did the synchronous communication, but you most of the time, and one example is that people just assume the happy path. They build the system according to the happy path. And once something happens, then, sales or finance or whoever has to deal with it has to figure out ways to go around the system to deal with this. But because we're thinking about with the message flow that can happen, and we're starting to modeling the message flow, it's for some reason people think about the problem and go into the problem deeper, and they figure out which alternative paths there are.
Yeah. Which
is a very interesting exercise that a lot of people that I talk to say, because of that, asynchronous communication is harder. It's not. We actually start going over all those alternative paths. And another thing that I find very interesting is that, and that ties in with microservices, because when you start embracing event-driven architecture, you pick up a message, do a very small thing, and then delegate all of the other work that you normally would do inside a single ASP.NET controller or whatever, inside a web service. You start delegating small parts to other components so that you actually get those microservices that a lot of people want, which are just actually very few lines of code. And once you start designing your message flow and your components, you can literally take one of those components or message handlers or whatever you want to call them and say to a junior developer, look, we've got a message coming in. It needs to do this. For example, store data in the database, calculate something, send out an SMS or whatever, a text message. And when you're done, publish this message. And even junior developers, while they don't have to see the entire message flow and figure out what's happening throughout the entire system, because that's what architects, for example, do, people designing the system, they can pick up a very small piece and develop it very easily, and it's reviewable, small PRs, etc., etc. And I think that's even if the downside are you need more documentation and everything, there are also benefits that aren't directly tied into the fact that you're using queues, but more that you think better about the flow throughout your system, and that junior developers can also participate very easily in developing small features.
Yeah, because they have tight boundaries.
Yeah, exactly.
Like you mentioned microservices, and is microservices, in your experience, an actual thing where you can show someone a reference implementation, or is it more of an idea of making smaller things than maybe would have done in years and decades past? And in your view, what's the difference between setting up a series of independent message handlers versus setting up a microservice? Are there tried and true things that you look for to define it, or is it just more of a general idea of breaking things up more?
Personally, I've never looked at it as something that I want to achieve with building systems. It's more like I've looked at the way I've been building systems, defining small things in many, many places, and then say like, okay, this is something that I could call a microservice. And it has influenced me somewhat, the idea of doing microservices and including that into my system. But it's not something that I've ever wanted to achieve, because if I look at it from a distance, and I mean, lots and lots of people are talking about it and promoting microservices. But if I look at it from a distance, it's very hard to, I mean, initially I wondered, like, you have all these functions or methods or whatever you want to call them in your system, and then suddenly you start breaking them apart and you're communicating out of process. And how can that solve any of the problems you are having? And a great example is a question on Stack Overflow where some person asked the question, and it's a very, very old question. And he says, like, I've built my entire system according to a microservices or architecture. Now, when I have a single user do a single action on my website, I end up with 30,000 HTTP requests. Some person responded and said, I don't know much about microservices, but that seems like a little bit too much.
Yeah.
I tend to agree. And I know that if you approach it from that perspective, just all your functions and the old monolithic way of thinking, if you can call it like that, start breaking up your system like that, I don't think it will do you a lot of good. So I think you need to embrace multiple things like domain-driven design, where you create bounded contexts and look at your entire domain and how to split that up and then you can find proper microservices to develop, etc. Other than that, I don't know if I'm much of a microservices expert, if you can call it like that.
So, didn't know if anybody noticed, but I do a weekly podcast about software topics, and I've talked to so many people, and I asked so many people that question, and I still have not found a microservices expert. And I look back to when service-oriented architecture in the early 2000s was being talked about at every technology conference, and now it's not. However, some of the ideas have permeated, and some good things, some good learning, good ideas came from those discussions. But a thing called I do service-oriented architecture, it kind of fell out of favor. It seems like what's happening here, where enough people have had a bad experience with a system that was too big, that didn't have enough boundaries to map to the actual business context that it was serving. And they said, "Oh, this is way too big. We should have broke this up. Next time, we just need to break it up and distribute it, because I do not want to get back in that situation and the pendulum swing to the other side." But in the meantime, enough people learn about good old distributed systems, good old asynchronous messaging versus synchronous, and all the different trade-offs, and how to debug and how to trace across different processes. And so, a lot of people talk about microservices, but then it's just going to come back with, okay, well, now more people learned some good ideas to take away from the discussion. That's what it seems like.
Mm-hmm. Yeah, for sure. I think that's like what you said with service-oriented architecture. And I mean, service-oriented architecture had some very good things, but it was the same time that SOAP and XML and WSDL and I don't know what else
and
got introduced. BizTalk, yes.
Brokers.
What I learned is that there were companies like Microsoft and IBM and I don't know who else. They were trying to solve a problem they had at the time, where they were trying to connect an ERP, a CRM, and I don't know what else kind of system they were having, their custom built systems. And they needed something in the middle to make sure that these systems could talk to each other.
Yeah.
Whereas service-oriented architecture was a completely different approach. It was trying to get away from those monolithic systems and build more modularized, componentized systems. And they were trying to find, I like the word right-sized services, because it still doesn't say anything. I mean, the word services is overused.
Yeah.
But I think we're looking for the right size of services. And we were doing that with service-oriented architecture. We were doing that with object-oriented programming. We're doing that with microservices. And like you said, there are the last 7 years, so many new developers have come in. Everyone is looking for how to divide up all those components and find the right size. But while people were trying to find the right size with service-oriented architecture, they had the word service, and IBM and Microsoft introduced web services with the WS DevStar specification, and they were just connected, and everyone was trying to do RPC over those web services, and people failed miserably. Not everyone, but a lot of systems using web services, they didn't work as expected. And that's when we started abandoning it, moved on to the next phase. And we just had microservices, apparently, because although it's sometimes still a hot topic on conferences, I think we're slowly moving on to the next phase. And I hear the vertical slices more and more. And I think that's a very interesting next phase, because we've been, and I know you've been talking about it as well, with layered architecture and the onion architecture. But where people have traditionally tried to separate concerns with all those layers. And we've got a great blog post on the particular software site where a colleague of mine mentioned it. It's like when you try to split those concerns into different layers, it's like splitting an atom. Because when you talk about loose coupling and high cohesion, those layers, they have high cohesion, but it's not everything. For example, I don't know, a customer name has not so much cohesion with something like, I don't know, the price of a product. So we can split those up, and then you get those vertical slices where you model your domain in vertical slices. And you can never remove all the coupling, because then you have things that don't work together and you don't have a system. So there always needs to be some coupling, but you try to minimize it as much as possible. And I don't think trying to introduce loose coupling between horizontal layers works, but thinking more about the domain model in vertical slices and see what we can separate. So instead of having, I don't know, an order where we have customer details, where we have product details like price and everything, all tied into one, storing that inside a single transaction, that doesn't make sense, because that's where lots and lots of coupling is introduced and where lots of locking is introduced. And if we can separate those, I think that's very interesting.
Yeah, it is. I would love to carry on this conversation. It's so good. And I was so excited for, like you mentioned, all the developers who are in the first phase of their career. And they're hearing a lot of this for the first time, and they're learning the different trade-offs. And I hope this is useful to them, that, there's not just a one-size-fits-all to go after. It's really an analysis. It's not a technical solution. It's understanding how the business process naturally works and make sure that the software aligns to the essence of that business process.
Exactly. And there's no right solution or single solution. It's all trade-offs. And I think that's important to understand when you start working, because I've heard it many times, and I've probably said it as well, like, this is perfect, we should use this everywhere. And in the past, I've seen a lot of reference architectures where people say, like, all our systems need to work according to this reference architecture, because then everyone understands it. But like you say, it needs to align with business processes, etc. So you can't have a reference architecture where you shove every system into, because that's not how systems, and that's not how businesses work.
That's right. Yeah, reference architectures fit for demonstrating patterns, but not for dictating how an entire organization will structure every application.
Exactly. Yes.
Awesome. Hey, well, Dennis, thank you so much for coming on the podcast and sharing with us your thoughts on distributed systems and microservices. I appreciate it.
Yeah, it was an honor to be here. Thanks for inviting me.
Oh, my pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.